The trick about this is that you want to make sure that you're reading out only the voltage that is generated by the light that's falling upon this. Many detectors, not all, but many detectors of light work in a way that is broadly similar to the way the camera in your cell phone works.
Mm,
Camera in your cell phone is referred to as a CMOS sensor. The fundamental technology is a little piece of silicon, which when light travels in and hits it, it generates a little bit of charge, which you can measure as a voltage. And you build into this silicon, since it's the material of computer chips, small amplifiers that allow you to sense that tiny voltage. And so in that way, you're reading out the amount of light by how much voltage you have. So the trick about this is that you want to make sure that you're reading out only the voltage that is generated by the light that's falling upon this. And the problem is that voltages can also be generated just by random thermal noise. Everything is always in motion. And so you do tend to read out some amount of thermal noise in the form of what's called dark current. That's
oh,
the electricity that you get when there's no light on it. That is what principally drives the temperature at which you have to cool your detector. And because the energy in the light, the energy in the photons of light, it would be lower and lower as you move redder and redder in color. As you
mm,
move to those longer red and then infrared wavelengths, the photons get less and less energetic. And so you need less and less energy in the sensor to thermal
mhm.
energy to generate dark current. And so you have to cool them further and further.